Certainly. The script without the timing is as follows. A surprising cosmic event is taking place in the vast and enigmatic depths of our solar system. It has the potential to alter our understanding of the universe and even put our very existence in jeopardy. Pluto, the far-off Bantam planet once venerated as the 10th planet in our nearby planet group, is presently at the focal point of a galactic tempest. A troubling scenario has been suggested by recent calculations. Pluto and Neptune, two distant neighbors, may be heading toward collision. Famous scientists like Michio Kaku and Neil deGrasse Tyson have expressed their concerns about this potential disaster, which has shocked the scientific community. What sequence of events could cause such a cosmic shock, and what might happen to Earth as a result? Pluto's excursion around the Sun is set apart by its exceptional attributes in our nearby planet group. Pluto has not completed a full revolution since its discovery in 1930, and its orbit lasts 248 years. Adding to its interest is its profoundly curved circle, which digresses from the almost round circles of the significant planets. Pluto's orbit is steeper and more erratic than those of the other planets due to its 17.18-degree tilt to the ecliptic. It is important to note that Pluto's orbit crosses Neptune's orbit about once every 20 years. This puts Pluto closer to the Sun than Neptune does, which defies expectations based on where the two bodies are in the solar system. Regardless of these orbital convergences, no impacts among Pluto and Neptune have happened. The intricate gravitational effects of other planets provide the explanation. Soon after Pluto's discovery, astronomers began examining its orbit, which presented a puzzle to them. Pluto's orbit has a strong tilt and an elliptical shape, in contrast to the orbits of most planets, which are relatively close to the ecliptic plane. The stability of Pluto's orbit in this complex environment demonstrates the complex nature of space mechanics, despite the fact that its orbit intersecting Neptune's may suggest a collision scenario. Understanding the motions and gravitational interactions between Pluto, Neptune, and the Sun is the goal of the so-called three-body problem in space. This puzzle reveals insight into the intricate transaction between their circles and gravity. This cosmic puzzle can be solved with the help of terms like orbital precession, latitude correction, and the Kozai mechanism. Astrophysicists believe that Pluto and Neptune's orbital precession, which keeps planets in their orbits, plays a significant role. The term implies that when Pluto crosses Neptune's circle, it is somewhere around 90 degrees away from Neptune, forestalling possible crashes. Latitude correction ensures that when Pluto comes close to Neptune or the other giant planets, it will be higher than their orbital planes, protecting it from collisions more effectively. Even though Pluto's orbit around the Sun appears to be random, the Kozai mechanism explains why it stays the same over time. Mathematical reproductions since the last part of the 1980s have shown that in spite of the fact that Pluto's circle is actually turbulent, with little beginning deviations prompting tremendous changes north of millions of years, it stays stable throughout very prolonged stretch of timescales. Even though Pluto's orbit appears to be erratic, this suggests that it follows a structured pattern that helps control the chaos. We now know more about how large planets like Neptune, Jupiter, and Saturn affect Pluto's path around the Sun thanks to recent computer simulations. The fact that Neptune has a one-of-a-kind relationship with Pluto in which it completes 3 orbits in comparison to Pluto's 2 makes a significant contribution to the stability of Pluto's orbit. The enormous gravity of Jupiter has a significant impact, and Saturn's, despite being weaker, also has an impact. Extensive testing has shown that Pluto's safe and stable movement through space over billions of years has been made possible by the combined effects of Neptune, Jupiter, and Saturn. In light of discussions about the possibility of a future collision with Neptune, it is essential to comprehend Pluto's orbit. This information highlights how gravity and orbital mechanics can bring seemingly unstable orbits back to equilibrium and sheds light on the dynamic nature of the solar system. To better comprehend our place in the universe, it is essential to continue observing and researching these phenomena. The unpredictability of celestial bodies and the way even minor shifts in a body's position or speed can dramatically alter its long-term trajectory are perfectly exemplified by Pluto's orbit. Pluto's orbit stability over billions of years suggests that there is underlying structure, despite the inherent chaos. We are constantly reminded of the changing nature of the universe by the chaotic nature of celestial orbits like Pluto's. Pluto's case demonstrates the limitations of our knowledge, despite our progress in space understanding. The stability and orbits of other objects in the solar system are affected by the presence of the giant planets in Pluto's orbit, as is demonstrated by the gravitational influence of those planets on Pluto. This information is useful for understanding the larger dynamics of the solar system. In the midst of these conversations, unmistakable astrophysicists, for example, Neil deGrasse Tyson and Michio Kaku, are communicating worries about a likely impact among Pluto and Neptune. The expanding knowledge of celestial mechanics is an exciting aspect of astronomy, according to Tyson, who is well known for his work reclassifying Pluto as a dwarf planet. He sees Pluto's reclassification as a correction to our growing understanding of the Sun's orbiting objects rather than a demotion. Tyson cautions general society about the potential peril presented by Pluto's flighty circle, recommending that a crash with Neptune is a genuine chance. He emphasizes that such an event has the potential to upset the balance of the universe and have catastrophic effects that reach all the way to Earth. It would be a significant and unusual occurrence in our solar system if Pluto and Neptune collided. Due to Pluto's smaller size and icy composition, a significant amount of energy would be released in the collision, which could shatter the planet. A collision of this kind could leave debris all over the solar system, putting other planets and their moons in danger. For Neptune, the effect could change its environment and circle contingent upon the particulars of the impact. Theoretical physicist Michio Kaku, well known for his work on string theory and popular science, provides a novel perspective on this scenario. Kaku sees the investigation of Pluto and its circle as a brief look into the eventual fate of room investigation. Future space missions could benefit greatly from knowing more about the intricate orbital dynamics and gravitational interactions of planets like Pluto. Kaku is of the opinion that the knowledge gained from studying Pluto's orbit could be used as a model for approaching and comprehending other celestial bodies. Planetary motions and interactions, such as the gravitational dance between Pluto and Neptune, are connected to fundamental physics principles, according to Kaku, who frequently emphasizes the close connection between theoretical physics and celestial mechanics. His work on string theory aims to explain the universe's fundamental forces and matter.